Our first lesson is on points, lines, and planes. The objective is to understand the basic terms and postulates of geometry. First definition is undefined terms. And these are the basic ideas that you can use to build the definitions of all other figures in geometry. There are three undefined terms. First one is point, second one is line, and the third one is plane. They're not defined because their definitions would require terms that also need defining. So these are our basic building blocks for our definitions. So we're going to use these undefined terms to define other terms. So the first one is a point. Point indicates a location and has no size. You can represent a point by a dot and name it with a capital letter. So here we would call this point A. Next definition is a line. A line is represented by a straight path that extends in two opposite directions without end and has no thickness because it is made up of infinitely many points. If a point has no dimension, has no thickness, then a line doesn't have any thickness either. But we can represent it by drawing a line. So we can name a line by any 2 points on the line. So here we have line AB. Note the line notation is an arrow over A and B. Or we can call it line L, simply because they put an L, a script L at the end of the line. Next definition is a plane. Plane is represented by a flat surface that extends without end and has no thickness because it is made up of infinitely many lines. A line has no thickness, so a plane has no thickness. Let's represent this plane, however. We usually represent it with something that looks like a parallelogram. And we can either put a little letter in the corner, or we can name it with 3 points that are in the plane. So here we can call this plane M, because we have a script letter M in the corner. Or we can call it plane ABC, because ABC are 3 points in the plane. Points and lines that line the same plane are called coplanar. All points of a line are always going to be coplanar. Space is the set of points in 3 dimensions. A segment is part of a line that consists of 2 endpoints and all points in between. Let's draw an example of a segment. I'll draw a line, but the part of the line that's just between the endpoints A and B is called segment AB. Note the notation is just a straight line over A and B without the arrows on the end. A ray is part of a line that consists of one endpoint and all the points of the line on one side of the endpoint. So let's look at this ray. We'll draw an example. This we will call ray AB. So you put the endpoint always goes first, and then the ray notation is just a segment with an arrow on one side. If we look at this other segment, let's look at another example. See here on this ray, we're going to name this one would be called BA because B is the endpoint. And even though it's going to the left, you still put the same notation over the top of it. Just name the endpoint first. Next, we have opposite rays. Opposite rays are two rays that share the same endpoint and form a line. So if we look at this example, we have ray BA with endpoint B going to the left through A, and we have ray BC with endpoint B going to the right through C. And those are opposite rays because they form a straight line. Finally, a postulate, or it's also called an axiom, is an accepted statement of fact. So postulates, like undefined terms, are the basic building blocks of the logical system in geometry. Good thing about postulates is that you accept them as fact. You don't have to prove them. We can use them to prove other things later that we're going to call theorems. So let's look at some examples. Problem 1, we're naming points, lines, and planes. What are two other ways to name line AB? Line AB is going through the plane, and the dotted lines represent the line as it goes underneath the plane and comes out from underneath the underside. That's why those lines are dotted. So what are two other ways to name line AB? We can name it with two other points that are on the line. So we could have named it AF with the line symbol over the top. We could have named it FB with the line symbol over the top. But since they also put a script L at the end of the line, we could have called it line L. What are two ways to name plane Q? Planes can be named with any 3 points that lie in the plane. So we could have named it plane EAC or plane CED would have been another correct name for it because those are 3 points that lie in the plane. Note that Q is not a point in the plane. Q is the letter that they put down in the corner of the parallelogram representing the plane, but there is no point beside it. So that's why they called it plane Q. The other names are 3 points in the plane. What are the names of 3 collinear points? Collinear means they lie in the same line. So E, A, and D are 3 that lie on the same line. Another example would have been B, E, and F because they lie on the same line. What are the names of 4 coplanar points? Coplanar points, 3 of them can be on the same line, but the other one is not on the same line in this drawing. So E, A, and D, and C are in the same plane. In problem 2, we're naming segments and rays. Question A, what are the names of the segments in the figure below? So the figure, we have segment MN. Don't forget your segment symbol over the top. We have segment NP. But we also have a third segment. We have a segment MP between points M and point P. What are the names of the rays in the figure? Now, rays is a different ray with each end point that it has. So let's look at the rays that would have an end point of M. So we have starting at M and going through N. We have a ray starting at M going through P. Now let's look at the rays that have N as an end point. We have NP ray, and we have ray NM. Those are the two rays that have N as an end point. And now let's look at end point P. We have PN, and we have ray PM. So we have 6 rays that we can name. Part C of the question, which of the rays in part B are opposite rays? Opposite rays have the same endpoint, go in opposite directions, form a straight line. So that would have to be NM and NP are the 2 rays that are opposite. On the next page of notes, when you have 2 or more geometric figures, their intersection is going to be the set of points that the figures have in common. So next we're going to have our first 4 postulates. The first postulate says if through any 2 points there's exactly 1 line. So here we have line AB or line T. That's how we could name that one. The second postulate says if 2 distinct lines intersect, then they intersect in exactly 1 point. Here we have line AE, and we have line DB, and they are intersecting in point C. Postulate 3, the third one, if we have 2 distinct planes and they intersect, then they are always going to intersect in 1 line. So here we have plane. Let's look at the plane that's horizontal. It's yellow in your picture. We can name it with 3 points. We have plane STW. And then the other plane that's intersecting it is plane STR. And they're going to intersect in line ST. So even though we have to draw them finitely with edges that look like rectangles or parallelograms, they actually are representing planes that go infinitely. So that's why they're not intersecting in just a segment. They go on infinitely, and they're intersecting in a line. Postulate 4, through any 3 non-collinear points, there is exactly 1 plane. So non-collinear means that any 2 of the points are going to lie on the same line, but the third point does not lie on the same line. So that makes them 3 non-collinear points. Last definition is a net. And a net is a 2-dimensional diagram that you can fold to form a 3-dimensional figure. So a net shows all the surfaces of a figure in one view. We're going to use the net of a cube in class to illustrate points, lines, and planes. In problem 3, we're finding the intersection of 2 planes. So we have plane EHG, it's kind of the horizontal plane, and the other plane is EHA, and they're going to intersect in line EH. 2 planes always intersect in a line. In problem 4, we have a box. Each surface of the box represents a plane. Which plane contains points J, M, and L? It's the top plane. The top plane, and we'll name it plane JML. The next plane is which plane contains points L, P, and Q. Well, L, P, and Q are over on the right side. So that plane, we'll say that that's the right side, and we will call it plane LPQ. The last problem is identifying a solid from a net. Now, a net, once again, is a two-dimensional representation of a three-dimensional object. So this net below folds into a cube. Which letters will be on the top and the front of the cube? So just remember that the letters, when you fold these into a cube, the letters have to be on the outside of the box, not on the inside of the box. So that is going to mean that we're going to fold B. We're going to fold B down to form the top of the box. C and E would fold in to form the sides of the box. A would fold under to fold and form the bottom of the box. So the front of the box would be D.